through what is a computer. That was interesting. Basically, we've gone through like very basic programs so far, so like printing stuff out, variable assignment. So this is basically taking a bit of data and storing it in a named thing that you can reuse later. So you're going to see this all the time. This will print out the value 5 to you, because it basically goes, oh, this is a variable. Where have I seen that before? Figures out what value it had. I'm trying to condense like 2 hours of content into 10 minutes. Let's see if I can do it. Variables don't always work together. Like you can add you can add words together, you can add numbers together, but you can't add numbers to words. That's what that slide means. This is because variables have types, which is like if you have a bit of data in your program, the computer knows what kind of data it is, whether that's a number or like a word or a dictionary or a list we'll see more of this later on. You can get them to work together by forcing them to be a different kind of type. You can do maths. Maths is fun. Don't divide by 0. You can get input from your user. So this is like if you want to be interactive with the user, you can use this kind of syntax, which basically waits for the user to type something and hit enter, and then uses what they did later on. So this program asks your name, gets you to type your name, and then says, nice to meet you, name. Good segue for those of you who haven't met me. I'm Lloyd. I run this course. Yeah, this times is by 2. These are comparing things. Let's not bother with that. And then the important one was control flow. I'm going to go through this a bit slower because I think people who were here last week might appreciate going through this. But control flow is a way of choosing which bits of your program to execute based on certain conditions. So this program here gets the user to input a number, checks the value of that number. If it's bigger than 10, it says it's bigger than 10. If it's less than 10, it says it's less than 10. And these basically, this is what we call an if statement or an if-else statement. And this bit here is what we call a condition. And this could be anything. In this example, it's we're asking the program, is the value of x bigger than 10? But this could be something like much more complex. This could be if the United States impeaches Donald Trump, do this. And you could have like a bit of code that this then goes and calls and checks news sites to find out if Donald Trump's been impeached. This could be else if Facebook is running at the moment. And this then goes and checks the Facebook website to see if it's doing anything. So this sort of control flow if-else architecture is used to do certain bits of code under certain circumstances and other bits of code under other circumstances. That is the gist of it. And we ended last lecture with a little challenge where everyone had a go at, I don't know why I'm wielding this like a staff. Everyone had a go at producing a program that played Marco Polo. So for those of you who aren't familiar with the game, someone yells Marco. In this case, the computer yells Marco. And then the user needs to type exactly Polo, and we needed our program to check whether the user had correctly entered Polo. Other than new people, because I'm aware you will have a lot of questions about everything I just said, does anyone who did come last week have any questions? About anything at all, including like organizational stuff or other stuff in general? Okay, in that case, I will start continuing. People who weren't here last week, don't worry. We will send help at the first break, which will be probably fairly soonish into it. Also, other question, which normally gets asked by new people, there will be pizza. Yes. That was very well timed, yes. There will be pizza. I don't know what time it's arriving, but it will turn up at some point. So if that's why you're here, don't worry. Cool. So yeah, this is what we saw last time. And this is more or less what you should be able to do now. So this is your skill set so far, which should hopefully expand over the next week, a couple of weeks. You can return things to the user, which is important. If your program does something, you want to be able to tell whoever's using it what it's done. You might be performing like some computation, you want the result. You might be manipulating some data, you might be looking up some data, you might be doing anything, and you want to give that to the user. George, are we recording, by the way?
Yes.
Excellent. Receiving input from the user is useful. So this is one way in which our program can interact with the real world. In other circumstances, you might want to collect data from a file, you might want to access the internet, you might want to do anything. But in this case, the only interaction we've got with the real world is the user so far. But that, in and of itself, is already quite useful. And the most important sort of general thing we can do is basically storing, using, and comparing data. Computers operate on data. I mean, humans do as well, we just don't really think about it like that. And the ability to store it, reuse it, change it, modify it, see what value it has, do something based on that value is immensely important. And it's probably one of the most fundamental things in computer science and programming. Cool, so this is, maybe we should go through this a bit more slowly, given how many new people we've got. This was the Marco Polo game we went through last time. Yeah, I will go through this. So this basically just says Marco to the user, waits for a response, checks if they've said polo. It says, oh, you win or you lose, basically. And then it stops. What we're going to look at today is being able to produce a program that does things more than once. So the idea being that if the user gets this right, you're going to keep playing. You're going to keep saying Marco, and they're going to keep saying things, and hopefully they're going to say polo. And you're only going to stop when they get it wrong. Because if anyone's seen like the game Marco Polo, like you run around saying Marco and Polo and Marco and Polo and Marco and Polo, and it keeps going until someone like does something wrong. So the aim of what we're doing here is to repeat this. Yes, I will go through the content actually, and then we'll take the break. And there are other things we might want to do. We might not want to play forever. We might want to play a certain number of times, or maybe just forever. Maybe we want to be locked in this infinite game of Marco Polo until we die. We will be able to do all three things within the next half an hour, I should hope. So what we're going to do first is the first one. And we're going to rephrase it slightly. So we're not going to keep playing until they get it wrong. We're going to rephrase this slightly, and we'll see why, to, while the user answers correctly, keep playing. And the reason we've renamed it that way is because we're introducing what we call a while loop. So this is one example of how you can do iteration in Python or programming in general. And iteration is literally just doing things n times rather than one. So you take a bit of code and you do it more than once, or maybe more than once. So this while loop looks like this. It's kind of similar to the if statement in that you've got a keyword, a condition, a colon, and then indented code that happens within it. So rather than it being if some condition, it's while some condition. And what this means is this is sort of like having a load of if statements in a row with the same condition, is it will check this condition, it will do something if this is true, and then it will go back and check again. And if it's still true, it does it again. And it goes to the top and goes, oh, if it's still true, it does it again. And if it finally gets to the top and goes, oh, it's no longer true, or maybe on the first go through, it wasn't true in the first place, it then skips the whole indented block and does whatever is down here. Exactly the same way as we saw in the if statement. The only difference here is that it will do the indented block for as long as that condition is true. Any questions so far? Okay, cool. So, what we might want to do is play forever. And it's easy to have a condition that's always true. You just use true. So this loop is exactly the same Marco Polo game we had before, except it runs forever. So this is saying, this condition here is saying, while true is true, which is always true, do this. So it runs this code, plays Marco Polo like we saw before, except instead of exiting, it now goes back to the top and checks if true is still true, which it is. So it plays again, and does the same again, 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 and again, and again, and again, and again, and again. So you can run this, and it will run forever, or until you kill it, which you can do. But obviously this isn't super useful. We don't really want to be locked at our computer playing Marco Polo to the end of our days. So we want to use a more useful condition, a condition more importantly that we can change. So this is where our knowledge of variables comes in useful again. So we introduce a variable called keep playing, and this we've named it appropriately so like we can look at it and remember what it means. But keep playing is a variable that it basically tells us should we keep playing or not. If it's true, we keep playing. If it's not true, we stop playing. So at the start of the game, we want to play. So keep playing is true. We want to keep playing because we're just starting. So now when we do while keep playing, Python's going to look up the value of that variable in the same way that it's always done. It's going to look up the value of keep playing and see that it's been set to true. So now it thinks of this as while true, like before. And true is true, so it does the code. It goes through this code, and we're not going to worry about it just yet. And then it will go back to the top and check the value of keep playing again. Now, so far all we've seen is this keep playing is true, so we'd think that maybe this goes on forever again. But the catch is that, as we saw in last lecture, we can reassign the value of keep playing to something else. Or in this case, when the user loses the game of Marco Polo, we can set keep playing to false. And if we set it to false, when we jump back to the top of the loop, it's going to check that and say, oh, keep playing is now false, so we don't execute the code in this while statement. We stop playing. I just said a lot of words very fast. Has anyone got any questions so far? Don't be afraid. Okay, good. So the challenge, and we will take a break for this because I can also send people to help new people, is we're going to see how we can use a while loop to print out all of the numbers from 1 to n. So if the program is going to take, or the user is going to type in a number, say like 5, and the program then needs to print out 1, 2, 3, 4, 5. You do have, based on last week and this week, the right knowledge to do this, trust me. I appreciate that it's going to be difficult, because obviously you've not even thought about this for a week, or even at all if you're new. And this is all very fresh, especially the while loop stuff. So what I first want to do is encourage everyone to have a go. If everyone needs the site that we used for programming last week, I'll put it up. And we're going to send helpers around, particularly to new people. So for those of you who weren't here last week as well, this is where we do or for this week at least, we will do our programming. So this is called Repl.it, which is repl.it. And if you go to this website and hit new REPL, hit Python and hit create REPL, you will get an environment like this. And basically on the left-hand side, you can type in Python code, you hit run, and it does it on the right. I'll quickly do an example. So you might do print hello. If you run that, it will say hello. So for those of you who are new, can you get to this state? So go to this website, start a new REPL, do print hello, and then put your hand up once you've done that and someone will come and help you. Or if you're having trouble with that, put your hand up and someone will come help you. If you're not new, I want you to have a go at printing the numbers 1 to n. So I'll start you off. So we're going to have a variable called number of times, which we're going to get from user input. Remember from last week that that's going to be a string, so we need to make it an integer. And then we want to use number of times to print, obviously this isn't the code, we want to put 1, 2, 3, 4, 5, 6, whatever, until we get to number of times. Does that make sense? Is anyone unclear about what their next step is? Yes. I will come and help you. Can I zoom in a bit? Absolutely. Okay, unless there are any more questions, have a go and put your hand up the moment you get stuck with anything or you forget something. Forgetting things is fine. Okay, go. Helpers, can you make yourselves obvious? So I'm going to go through this. It sounds like you've had a lot of success, so I won't linger too much. But essentially what we want to do is keep track of how many times. There's a lot of different ways to do this, but the way I'm going to go through is we want to keep track of how many times we've printed out something, or what number is next to print out. So I'm going to have a variable called next to print. And at the start, this is 1. And what we want to do is we want to start off by printing this, and then keep printing out the next number until we reach number of times. So what I'm going to do is basically check if the thing we want to print is smaller or equal to the number of times we want to go. Because the number of times we want to go, like if that's our n, That's the biggest number we want to print. That's why we're doing this less than or equal to. So now what we want to do is print out the thing we want to print. And the important step, the thing that makes this work, is that we then want to increment this. So the next number to print is now going to be 1 bigger. And the way we do this, right, so this may or may not work. Let's find out. It does. So it's not perfect. There are issues with this. Can anyone spot an issue with this that I've not talked about? Don't worry if you don't, because I'm not expecting you to. Okay, so there is an issue with this. What happens if I type in 0 as my number? So you'd want this to maybe do nothing if I type 0, because 1 to 0, there are no numbers from 1 to 0. Oh, wait, no, maybe this does work. Does it work? What happens if I type 0 as my number? Yeah. Do you say it does nothing? Yeah. So when it gets to this condition, if I've typed 0, it's going to check if 1 is less than or equal to 0. And obviously, 1 is not less than or equal to 0. George, what was the problem you spotted? Okay. Well, that's a problem in and of itself, to be fair. Okay, I think this does work. This is fine. So this program does exactly what we wanted it to do. It goes from 1 to n, and it prints out all the numbers. So is everyone now happy with this? Is anyone still, except you guys on the end who I know will probably be unhappy with this? Is there anyone in this part of the room that's still unhappy with this kind of thing? If I slide that along. Cool, okay. Let's get back to the slides. Is there a clicker? No. So, we're not going to go through this, we're going to talk about it. How might we print out all the multiples of 3 lower than n? So rather than going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, up to n, we're going to print out only the multiples of 3. So we want to go, so let's say our n is 30. We want to print out 3, 6, 9, 12, 15, 18, 21, 24, 27. How might we go about doing this? What do I need to change about this in order to get this right? I think I can do this in 2 changes. Don't be afraid to have a guess, guys. Okay, so let's think about what this program is currently doing. So the first thing that's wrong already, if we want to print out 3, 6, 9, 12, or that, is that the first thing we've said to print is 1, which is very obviously not 3. So the first change I'm going to make is to start on 3. So now what this program does is it starts with 3. Let's say our number of times is 30. So actually a poor name now. Let's go back to calling it n. So let's say our n is 30. We want to check if, we're going to check if next to print is less than or equal to number of times. So we're going to go, is 3 less than or equal to 30? We're going to say yes it is. So we're going to do this. So we're going to print 3, that's good so far. And then we're going to add 1. So now we've got 4, and we've got, is 4 less than 30? It is, so we'll print it. So we've gone 3, 4. That's wrong, we wanted 3, 6. So what do I need to change to make sure I go 3, 6 and not 3, 4? Absolutely. So all we're going to do is change this to +3. And now, if it wants to load, this website is notoriously not great, which is why we're going to move off it next week. It's really thinking about it. Apologies, guys. Oh, thank you. See, it shouldn't be failing though. So Python is not a compiled language. So having errors in your program shouldn't mean it doesn't work, but very well spotted. I type 30. So there's still something not quite right. This now goes 3 to 30, but I said I wanted the multiples of 3 that are less than n. So all the things that are less than 30. 30 is not less than 30. What do I need to change? Bit louder. I think you were right, whoever said that. No? Okay. We just want to get rid of this equal sign. We now want to check if Nextprint is less than n, not less than or equal to n. And there we have it. That is exactly what we wanted. So we're going to move on slightly, but on the same topic. So we might want to still be doing things more than once, but we might want to think about it in a different way. We might not, rather than thinking about it as while something is true, keep doing it, we might want to do something a set number of times based on something else, or for as long as something is true, which is the same thing, but like a different way of thinking about it. So currently what we do is, this is what I did when I did the slides, so this is how we did this program, which is almost exactly the same. Very consistent, Lloyd. So this was the program we just saw. This is the 1 to n, and this goes through and prints everything from 1 to n. What we might want to think about this is what we're actually doing is, for every integer between 1 and n, print it. That's like another way of thinking about this problem. And the reason we're thinking about this is because it's going to introduce what we call a for loop, which is everywhere in programming. You're going to see these things about 1,000 times. About 100 of those are going to be in this room. Basically, this does exactly what we said. This goes through every integer between 1 and n and prints it. And I'm going to talk you through the syntax we've used. So what we've got here is, rather than our while something colon, we've got for something in something, do something. And this is going to be the format you're probably going to, not always, but very commonly see it. This thing here is another variable. Just like x or y or whatever you wanted to call your variable, this is a new variable that you haven't done like I equals before. We use I because index, I guess, is where it comes from. Is it index, George? Where's George? He's gone. Yeah, so like, don't worry about the name. It doesn't have to be I. It could be anything. But the point is, this is a variable that is initialized here and only means something within the context of your loop. So this is like having a I equals at the start of your indented block. And the value that I has assigned to it comes from this second half, this range. So the range thing here doesn't exactly do this, but more or less produces a list, we're going to talk about lists later on, of the numbers 1 to n. So this sort of produces for I in 1, 2, 3, 4, 5, 6, blah, 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 n. And what that means is, on each time the loop is run, I takes on the next value in that list of numbers. So the first time it runs this block, I will be 1. So it prints 1. And then it gets to the bottom of this indented block and goes back to the top and takes on the next value of I. So in this case, it will be 2. So it will print 2. And then it will go back to the top, 3, print 3. And the reason this has n plus 1 here, I can hear people wanting to ask, is basically because this is a non-inclusive range. So this means it's 1 to n plus 1, not including n plus 1. So it includes the first number, it does not include the second number. I appreciate I just talked a lot. Does that make sense to... Let's start with anyone. Did anyone understand what I just said? I'm seeing a couple of nods. That's good. Can I get a hand if that didn't make sense, or there's anything that's unclear? Okay, cool. So now we want to use a for loop, so the new structure we just saw, to do the previous challenge. We want to print out all the multiples of 3 less than 3n using a for loop. There's a few different ways you can do this. You do have enough knowledge to do one of them. So can everyone start having a go at this? We won't spend as long on this as we did on the last challenge. I just want everyone to have a bit of a go. So your challenge is to use a for loop. I'll remind you of the structure of that. That looks like this. For I in range, and then a number and then a number. And we want to print all the multiples of 3 less than 3n. So it's ever so slightly different than before, because now we give n, we times it by 3. Is anyone unclear about what they need to do? Don't be afraid if you are unclear, we will help. Cool, I guess have a go then, guys. And please stick your hand up if you have any difficulty about anything. So this is what we had before. We're going to get rid of it because we want to do a for loop. So I want to print all the multiples of 3 that are less than 3n. There's a few ways of doing this. I'm going to show you one, and then we're going to discuss other ways. So what I'm going to do is I'm going to think about this. I'm going to first think about what I actually want to do. So I wanted to do, same as before, 3, 6, 9, 12, whatever, up to, let's say our n is 10. We want to go up to 27. And I'm going to look at this and think, like, how do I achieve what I want to achieve? And in my case, I'm thinking these are multiples of 3. So rather than, the more complex way of doing this would be to go through everything from 1 to 3n, check if it's a multiple of 3, and if it is, print it, which is fine. I imagine some of you, did anyone do that? Okay, so that's perfectly fine. What I'm going to do cuts out some of the legwork, which is why I'm going to go through it. Because cutting out legwork is like the name of the game in computing. So what I'm going to do is I'm looking at this and I'm thinking, this is the first n-ish multiples of 3. So what I'm actually going to do is not go to 3n. I'm going to go to n minus 1, which is why I've used n, because it does the one before it. And I'm now going to print out 3 times I. Because on the first loop, I is 1, so 3 times I is 3. On the second loop, I is 2, and 2 times 3 is 6. On the third loop, I is 3, so 3 times 3 is 9, so on and so forth, until we get to n minus 1, which in this case would be 9, and 9 times 3 is 27. Do we think this works? Hands up for yes. Hands up for no. Hands up for I'm too hungry to think. There's always a few. Yeah, so we're good. This does work. Charlie, you had a quizzical look on your face when you thought no. Can you explain to me why? Or what could have maybe been wrong with this? Okay, good question. So the question was, like, where have we defined I? How does Python know what value of I to use here? And it's a very good question because it's not super clear based on what we already know. And so what's important to know is that every time Python goes through the indented bit of your for loop, it takes values of I in turn from that range. So we've sort of got to do 2 steps of thinking. The first step is understanding what this range is. So in our case, that range is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first thing Python does is it replaces this range 1n, sorry, it goes up to 9, not 10. It replaces the range 1n with exactly that list of values, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then every time it goes through that loop, it takes the next value in that list of values. So it starts with 1 and goes, oh, well, 3 times 1 is 3. And then it goes back up to the top once it reaches the bottom and goes, well, what's the next value in that list? It's not 1 anymore, it's 2. So 3 times 2 is 6. And then when it reaches the end of that list, so it gets to n minus 1, it now knows, oh, well, we've done all the values, I can stop, and it will jump out of this loop and execute whatever is next in the program. Is that a bit more clear now? Excellent question. Are there any other questions about this, or why this works? Yep.
You can't reassign I in the form.
You can. He hesitates to say you should be able to. So the difficulty with reassigning I in a loop like this is it can interfere with the range that's used. I'm not going to delve into why we might or might not be able to. Generally, it would be considered bad practice to. There are very specific circumstances where you do want to. They're perhaps a little bit beyond the scope of this course. If you grab me at the end, I can talk to you more about this if you are interested. If you're not, I completely understand. Any other questions? So the other way you can do this, which I'm going to show you, is using a... Oh, yes, sorry.
If you want to make it so that after it prints the 3 times I, it does 4 times I.
Yeah?
How do you do that? Because when I did it, it was interfering the two. So we'll do one and then the other.
Oh, so you want it to do 3, 6, 9, 12, blah, 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 and then 4, 8, 12. Okay, so if you want to avoid interleaving the two, the way you do that would probably be to have a separate loop that does that. So I think really the question is, why is this different than just having print 4 times I in the loop? Is that the question?
No, is there like an end function so that as soon as it finishes, it prints 3 times I, it can go on to the next?
So what do you want the output to look like? Do you want it to be 3, 6, 9, and then 4, 8, 12? Or do you want it to be 3, 4, 6, 8, 9, 12? The first one. So that would be how you did this. Because it needs to, if you want it to finish printing all of those multiples of 3, it's important to remember the way this does this is like, it's not printing all of the numbers at once. This line does not print all of the numbers. This line prints one of the numbers. And what we're doing is we're iterating over that line. So we're telling the program, we want to run this line of code this many times, which in our case is 10 or 9. So then it runs this line of code 9 times. If you put another line in that loop, it's going to run that line of code 9 times as well, in that order. Sorry, I just saw Peter at the back. If you want it to do all of one lot of things, if you want it to run those 9 lines of code and then those 9 lines of code, you need to separate it out like this. Does that make sense? Okay, good question, very good question. So I will very quickly go through another way you could do this, and then we will break for pizza. So the other way you could do this is using something that I've not actually shown you yet, which is a bit of a cop-out from me. But essentially, the other way you could look at this is rather than going from 1 to n and printing out 3 times that, you might want to go from 1 to 30 and print out the relevant numbers. But I want to avoid all that horrible extra checking if it's a multiple of 3 kind of stuff, because A, I'm lazy, and B, that's telling the computer to do more things, and if you're telling the computer to do more things, it takes more time. And I want my answers now. So what I'm instead going to do is I am going to tell it to go to 3 times n, but I'm going to add an extra number here, which is what we call the step. And this tells the range function to not go 1 at a time. It now goes 3 at a time. So it starts at initially 1, and then goes up 3 at a time. What's the issue with this now? Can anyone think, based on what I just said? So if I start on 1 and I go up 3 each time, so it's going to start by printing, actually let's Sorry, the logic was based on printing the new I. So I want to start with the first one and then print that, and then print 3 higher than that, and 3 higher than that, and 3 higher than that. Can anyone guess what this is going to output now? Times 9? Sorry, yes, you were absolutely right. It would do that. But there's another issue with this, a very small issue. I think I'll just show you. So it's almost right. We're almost right. If I give it, what was it, 30? No. 10. It's almost right. It's going up in 3s, but it's 1, 4, 7, 10, 13. They're all 1 off. How can I fix this? What do I need to change? Yes, Charlie?
Range 0.
Yes. So I'm going to start my range not at 1, but at 0. And what this range statement now says is we want a range of numbers starting at 0, stopping before 3 times n, and going up in 3s. So it starts at 0 and goes up in 3s until it reaches 3 times n. And those are new values of I. So whenever this loop goes through its indented block of code, it will use those values for I. So it will use 0, then 3, then 6, then 9, blah, blah, blah. What's wrong with this now? It's better, but there's something wrong with it. I'll show you. If I give it 10 now, there's a random 0 at the top, and we didn't have that before. So if I want to get rid of that 0, what do I change?
Well, 0 to 1.
Hmm?
Let's start from 1. Make it start from 1.
Make it start from 1? Starting from 1 was where we came from. So if we start from 1, it'll go 1, 4, 7, 10.
Make it 3.
Make it 3. Yeah, so if we make it 3, we'll start from 3. We'll keep going in 3s. Or at least we would if it worked. There we go. Ta-da! And that's the way I would probably do this myself. Although the way I first showed you was fine. There are other ways of doing it. The checking if it's a multiple of 3 works as well. That is a lot of pizza. I'm going to just sort of start again, because there's going to be a bit of content delivery for a bit. So if you guys are still eating, that's fine. Has anyone got any questions about anything we've covered up to now at all? About absolutely anything? None at all. Excellent. How happy are you guys feeling with what we've just went through? So the while stuff, the for stuff. I see a thumbs up. That's good. Excellent. No thumbs down? No one desperately unhappy?
I just got pizza.
That is true, you did just have pizza. Right. Yeah, let's carry on then. So the next thing I want to talk about is lists, which is a fancy name for lists. It's basically just data sort of yeeted together somewhat. And these are really useful because sometimes you want to store a number of things and you don't know how many of those things you need. Or maybe you want to draw on a sort of list of data from the real world. And, or maybe you just want to deal with a lot and you don't want to have to rigorously write out a different variable for each of them. Maybe you know you need 100 bits of data and you don't want to have X, Y, Z, A, B, C, blah, 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 up to 100. And that's where lists come in handy. So we're going to use these a lot. You're going to see them everywhere, particularly in Python. They are literally everywhere. So I'm going to go through just some of the building blocks of how these work and what we're going to do with them. Cool. So these square brackets indicate a list. So everything in the square brackets separated by commas is an element of the list. What happens if I print X? Can someone tell me? Someone have a go? Or guess?
1 space, 2 space, 3 space, 4. Or is it just 1
Yeah. So as you might expect, it prints out exactly what you see here. So this append function here, this does exactly what you think it does. It appends something to the list. The thing we've not seen before, or we've not really talked about before, is this kind of notation. So here we've got x dot append. Now x we know is a list. And append is what we call a method for lists, which means it's a thing lists can do. And the way you do that is you take the list you want to do it on, and you do dot and the name of the method, which in this case is append. And append takes one what we call argument. The same way we had like print something, we have append something. So in this case, we're appending 5. So if you print x now, you get 1, 2, 3, 4, 5. So these are what we call a data structure, basically. These are really important. You're going to see them everywhere, but lists are the most common. That I've just talked about. I need to tidy up these slides, actually. Apologies. The important thing here is that you can have empty lists, and they are useful in that this immediately tells Python that the variable y has type list by doing this notation for empty list. So this is a list with nothing in it. And then obviously you can populate that with append. If you want to pull something out of a list, you use this notation. So you use the name of the list. So in this case, it's called mylist. And then you do square brackets with a number, which is the index that you want out of this list. So this gives you the third element. Trick question, what number does this print? 4, yes. So something which you just sort of need to accept is that in computers, we don't count starting from 1, we count starting from 0. So this is not the first element, this is the 0th element. This is the first element, this is the second element, this is the third element. So print my number prints 4 and not 3, as you might expect. For now, I just advise you to more or less accept that, which is not something I like saying when I'm teaching, but it's going to save you a lot of trouble. Maybe we'll go through that sometime. Those of you coming from, has anyone done MATLAB before? Yeah, those of you coming from MATLAB will not be used to this because MATLAB coddles you a little bit and starts things at 1 when they shouldn't. The other thing you do is you can go from the end of a list. So you can do mylist minus 1, and this starts counting at the end. So the minus first, minus 1, minus first. English doesn't really do that, but you start at the end and you count that way. So this will give you, someone tell me.
4.
I heard 4s, I heard 5s. So this is interesting. What is, it is 5. Why is it not 4, even though I just said we start counting at 0? Can anyone?
There's no minus 0.
Exactly, there is no minus 0. So Python knows that minus 0 is the same thing as 0. So if you do mylist minus 0, thinking, oh, maybe that's 5, it's going to go, oh, that's the same as 0, and give you 1. So minus 1 is what you need for the end of the list. Minus 2, minus 3, minus 4, minus 5. Something that's often really important is the length of a list, which is the same as the number of things that are in that list. And you do this by using len. That's how that works, basically. So what do we think that's going to print out? Any guesses? 5, exactly. So this is really useful because often you might have generated your list what we call dynamically. So the program has done something which has generated a list. Maybe you've got a file somewhere on your computer that has, I don't know, the example I usually use is the heights of everyone in the room. So you don't know how many people are necessarily in that room. So you might want to call len my list to find out how many heights you've got, for example. Maybe we won't bother with...
Playing around with our own lists.
Yeah, maybe let's not bother with this. Maybe we can talk about them. What do we think happens if we do this? What happens if we try and retrieve the 5th element of a list that's only got 3 things in it? Error. Is that what you were going to say?
No, maybe we get the second.
Maybe get the second. That's actually a really, really, really good guess. there are data structures in Python and other languages that do exactly that. So if you try and get the fifth, it'll like loop round to the second. But we're not going to see that on lists. Very, very good guess. The other guess was that there's an error, which is, I'm pretty sure what's going to happen. And it's going to say something like index out of bounds, which is saying the index you're trying to access is out of the bounds of the list. So the list is bounded by the fact that it's only got 3. So if you try and do more than the third element, you're going to get, sorry, the second element, you're going to get an error. The other thing I want to talk about is this here. I think we might have some slides on this. Do we have slides? We do. Yeah, I'm going to save that for a bit. Yeah, so the next thing I want to talk about is removing stuff from a list. This example really helpfully has like 1, 2, 3, 4, 5, which makes this kind of confusing. What do people think this is going to do? Two, 3, 4, 5. Let's try it. So what's the other option? What else could happen, maybe? 1, 3, 4, 5. Also a good guess. So the idea being that it removes the first element of the list, which in this case is 2.
You mean the element with index 1? Because the first element of the list is 1.
The 0th element is 1. I'm not going to use 1, 2, 3, 4, 5. I'm going to use 10, 20, 30. I'm going to do x.remove 10. So anyone who was very quick on watching what I was doing will have spotted that if you type this and then sort of hover your cursor at the end of this line, yeah, so there's a little spoiler. Because REPL is clever, it tries to tell you what the thing you're doing does. And this basically does exactly what Jess said, which is it removes the first occurrence of the value you give it. So if I do x.remove 10, it's going to look in the list for the first occurrence it can find of 10 and take it out of the list. What do we think happens if, I mean, I've kind of already told you this because of the spoiler, but what do we think happens if there were more than 1 ones in this list? What do we think would happen? Or what do we maybe know happens? Not quite. What's the other? So it could delete them all. What's the other option? Just deletes the first one. Thank you, George. What a star student you are. So if there's more than 1 element, it will just remove the first occurrence it finds. So if this was 1, 1, 3, 4, 5, it would then become 1, 3, 4, 5. This question is an interesting question. How would I go about removing the nth element from a list? Maybe I don't know what's in my list, and I want to remove a specific element. A specific index element, sorry. We do have a way of doing this based on what we already know. I think it's going to be easier using a new bit of syntax. So I'm not actually going to answer this question now. We're going to answer it a bit later. The other question at the bottom is, if you have a list of size n, how do you remove every single element of the list and get back the empty list? So we've got a list, and we want to get rid of everything in it and just get the empty list. How might we do that? Has anyone got any ideas? Wild guesses, perhaps? Using things we know about. Using a for loop? Excellent start. We can use a for loop. How might we go about doing that? Very close. So you could want to do something like, apologies to people on YouTube, you won't be able to see this. For I in range And then you're right, we want to start from 0, and what we want here is to tell it to go like all the way to the end of the list. And the way we're going to use that is we're going to reuse what we saw earlier, which is len. We want to know how many things are in this list. We're going to use len for length. Len, let's say our list is called x. And you're right, we probably do want to go to sort of length minus 1. Yes, we do. And because this is like a non-inclusive range, it's going to stop us just before that. So if we've got this loop, this is going to go through basically every number from 1 to length x, not inclusive. What can we do with this? Yeah.
Oh, I've got a question.
Oh, yeah, go for it.
Because if you have like the data that's like infinite long, it's going to take a long time. So there are ways to like speed it up instead of just going moving one by one.
There are, yes. There are things that will remove things one, but under the hood, they are probably removing them one by one.
Oh, okay.
Or I will discuss probably what they do under the hood later, because they're probably doing some very clever stuff with like in memory, which I'm going to discuss in a bit. But to be honest, computers are so quick. So if you were in the first lecture, I talked about the magical flattened rock, which is your computer. It can do things like millions and millions and millions and millions of time in like fractions of seconds. So removing things from really long data structures like this is like so trivial for the computer compared to the other things it does, that it will do it like quicker than a human could even comprehend. So, what was the question? Yes. So if we've got this for loop, what bit of code might we want here to remove everything from the list? You're very close. So the guess is, x dot remove I, which is very close. What this is going to do, so I is 1, 2, 3, 4, 5, whatever. This is going to go, okay, remove the first occurrence of 1 in x, then remove the first occurrence of 2 in x. But if x is, for example, I don't know, 3, 7, 8, 12. When it does x dot remove 1, it's going to go, what's the first occurrence of 1 in here? Oh, it's not there. I won't do anything. What's the first occurrence of 2? It's not there. I won't do anything. So when it gets to 3, it will remove 3. And then when it gets to 4, it won't do anything. And what you're going to be left with is 7, 8, 12, and not the empty list that you wanted. So what do you actually want to do? Or what could you do to remove everything? What could you use instead of I? That's a tentative hand there, Charlie.
Is there any way of like specifying that it's an index?
Yes, there is. How do we, so how do you remove index I? So let me ask you a question, or you guys a question. Yeah? I'm going to get to that. That is the correct answer. We'll get there. So the question was, how do we tell it that to use it as an index? So we remember from a few slides ago that we can do things like this to access the elements, right? So maybe we're starting this at 0. Sorry, actually, I should have said 0, not 1. Yeah. We're starting this at 0. Maybe we can do x dot remove 0 and remove 3, and then maybe x dot remove 1 and remove the first element, and then maybe this one and then this one. That seems logical. So maybe we'll try that. Let's see if this works. I mean, obviously, by the way I've phrased the question, you know it's not going to work, but let's see what happens. So if x is... and I do for I in range 0. So this is what we've got on the board, and I do x dot remove And then what I do is the value of x at index I. That's what this means. So x brackets I is the value in the list x at index I. Unless I'm very much mistaken. Oh, I need to print something, don't I? Well, the error tells you that it doesn't work. So this is giving us what we talked about earlier, so an index error saying index out of range. Can anyone take a guess at why we're getting an index error? Because the biggest index we're accessing is length minus 1, which is 3, so we should be accessing 12, sorry, I've used an extra number, haven't I? We should be accessing 12 when we get to I equals 3. What might be going wrong? Why does it think we've accessed something out of range? So the out of range exception is saying we're trying to access a value that is like beyond the end of the list.
Because you have deleting.
Yes. So every time we go through this loop, I'm deleting something from it. So if I do x dot remove 0, I've just got rid of that 3. And our new list is just 7, 8, 12. Importantly, it no longer has 4 elements in it. So when I get to, for example, if I then go through it and I do x dot remove 1, the value of x at 1, it's going to go, well, we'll remove the 8. And now this is size 2.
Just to change the value to 0.
Exactly. So the suggestion we got earlier from up there, and now again from down here, is to just use 0. So what this is going to do is it's going to go from, I is going to go from 0 to 3. But we're not using I in the loop. We're just doing something 4 times, which is we're removing whatever the 0th element is, or to an English-speaking person, the first element in the list. So if we start with whatever I've done on the board, 7, 3, 8, 12, and I just remove the first element, and then the first element, and then the first element, and then the first element, and I do that 4 times, we've deleted the list. So now, we get the empty list out, which is what we wanted. Is everyone happy with why the things that worked, worked, and why the things that didn't work, didn't work? Yep.
How about assigning empty list?
How about assigning empty list?
Yeah.
So just doing x equals empty list? Yeah, that works. Bit of a cheat. It doesn't so there was a question earlier about, is there a quick way to do this? That is the easiest way to do it. The reason I've shown you this was both A, to teach you some things, but B, you might, for example, only want to remove the first 4 elements or a certain number of elements, for example. So it's more useful to have this sort of general technique rather than just doing reassignment to the empty list.
So if you just wanted to remove a certain number of elements, would you do 0 to, or like how would you specify?
So I guess it's going to depend on specifically which ones you want to remove. But let's say I wanted to remove the first 4 elements of a list. I might do that. So this will remove the first 4 elements of a list. What might go wrong now? I heard words, but not what words they were. Which words? So, yes, good point. So the question was, what do we do if we want to remove something other than all of the elements? So if, say, we wanted to remove the first 4 elements of a list, we might do something like this, but there's something wrong with this. What's going to go wrong, or what could go wrong? What happens if x only had 2 elements in it? I'll show you. So this says index out of bounds, and it's saying 0 is out of bounds, out of range, which is saying that at some point we're trying to remove the 0th element of an empty list, basically. And this is happening because we've gone through this loop 4 times, and we're trying to remove the 0th element all 4 of those times. But after 2 times, it's gone. There is no list anymore. So if I were to do it like this, maybe you'd do something like this, for example. So this will check to make sure there's something in the list to remove, and now it won't break. This will always remove the first 4 elements of a list, or if there are a few of them, will remove all of them. Are they? Oh yeah, there you are. Sorry, looking at the wrong line. Thank you, George. I had my brackets wrong around. Now it works. Cool. Are there any questions about that or what I've talked about for the past few minutes? Okay, do I want to tackle this in 15 minutes? Maybe we'll start. So, take a moment to look at what is on the board. We're assigning a list to list 1. We're then saying that list 2 is the same as list 1. And then we're going to append something to list 1 and print out both list 1 and list 2. So I don't want to guess what happens. Just first instinct, wild guess. So that would be my first guess if I looked at this. I would think, well, we're appending 6 to list 1, so we should get 1, 2, 3, 4, 5, 6, that's fine. And we're printing list 2, and the last time we saw list 2 was here. So what actually happens is, both of these print 1, 2, 3, 4, 5, 6. Who said why? Why is a very good question. So the tricky bit here is what's happening on this line. So this line is saying list 2 is the same as list 1. So you'd think that that just takes all the values in this list and assigns that to list 2 as well, and you get 2 lists with the same things in it. Now that's where it gets you, because what's actually happening is we're telling Python that list 1 is exactly the same thing as list 2. Not as in they have the same things in them, as in they are literally the same list. We're just referring to it in 2 different ways. In the same way that George is one person, but I can call him George or Yorgos. He's got 2 names, but he's the same thing. And in this case, list 1 and list 2 have 2 different names, but they are the same list. They are the same thing. So if you append something to one of them, you will append it to the other one. Good question. How can you store a copy of list 1? So, I do have a slide for this. I'm going to skip to it. This is exactly how you take a copy. So what this does, so it's the same thing for like accessing when we did like square brackets and then 0 or 1 or 2 or whatever. This is what we call taking a slice. And the colon here says you're taking like a part of that array. So what you, list. What you can do is give it 2 numbers and say we want things between the 0th index and the 2nd index. But if you give it no index, it will go from the start to the end, copy everything and put it in a new list. So that's like functionally what you do if you want to copy a list. And we're going to talk a little bit more next week about what's actually happening under the hood. But for now, I think we'll stop there, unless there are any questions. Yes?
Is the slice inclusive?
Off the top of my head, the first one is inclusive, the second one is not. So it's the first, on the left-hand side of the colon, it includes that, on the right-hand side it doesn't. Could be wrong, try it out, let me know. Yep.
What's the use of making a list exactly the same when you can call it from?
Very good question. We're going to talk about that the reason I'm stopping is because I don't have time to answer that very, very complicated question. So the obvious question that we got there is, what's the point? Why would you ever want to assign two names to exactly the same thing? And we're going to see why next week. Yeah.
Is there a way for like a list and then have two numbers from the list and just swap it?
We will go through a very similar example next week. Mm-hmm.
What's the difference between dot and dot extend? Do they?
Good question. Harry, you know more about Python than I do. Or, yeah. Oh, okay, yeah. So basically, they just work on different. So that's actually. So full disclosure, don't know. I don't use Python every day. I don't know all of the little functions in it. So maybe I would, to answer this, show you how you might find out yourself. So the question was, what's the difference between x.append and x.extends? Was it extends? Extend. So what I might do is type extend. And then this little pop-up window is going to tell me roughly what it does. And obviously, you guys probably haven't come across the word iterable, so don't worry about that. But to someone in my position, and hopefully your position in a few weeks, you can look up things like this and try and understand what this does. And this tells me it's going to append elements from an iterable. So for example, a list is a type of iterable. I know this. You don't worry. I might give this a list, and it's going to append elements from that list to the list. If you were to try and, so for example, y equals another list, x.append y and x.extend y oh, yeah. Sorry. Don't worry about what just came up. I will explain that next week. I'm an idiot. That's what we want. So what we should get out now is this weird little thing here. So as you can see, the elements of this list are now 7, 12, a list of 3 and 4, 3, 4. So that's the difference between append and extend. If you append a list to a list, it adds that list as an element of the first list. So this is just what we call nested lists. So you've got a list within a list. Whereas extend takes every element and then puts those in the list. Good question. Yes? You just add it? Yeah. Yeah. Good question. So we'd probably use something, I think it's called x.push. It's just another function that does the same thing. Basically, there are a ton of things that lists can do. So when I said that append was a method of lists, lists have loads of methods for like doing stuff with them. We're going to go through more of them next week. X.remove is one of them, x.append, x.extend. They're all methods on lists. And if you know how to do all these things, you'll have like a huge arsenal of things you can use to make your own programs. Good question. Okay, I guess we'll end there. Thanks very much for coming. We should be in the same room next week, but keep an eye on the Facebook event because we were double booked today, and I don't really want to fight a philosopher. Any questions, please get in touch with me. I'm Lloyd. My name's on the Facebook event somewhere. I can give my email address or anything to anyone who wants it. Just message me or something.